All right, let's start off here on number 2. So we're just going to be combining like terms here. I see that this one does not have anything in front of this second parentheses, so I don't really need to distribute. On number 1, you do need to distribute that in there, but on this one, I'm just going to combine. So I have 5x to the fourth and 5x to the fourth, so that becomes 10x to the fourth. We add the coefficients, but the exponent stays the same. And then my next up, I got x to the third, so I have negative 1 and negative 3, so that makes negative 4x to the third. Negative 4x squared has nothing to add with, so I'm just going to keep that like that. And then negative 7x has nothing to add with either. Just a quick note here on this one, you need to, number 1, you do need to distribute that there. And so this switches kind of everything. And then this first one's going to stay the same, and then you combine the like terms. So that's the first step there. All right, these ones we're going to state the degree, and so the degree is the greatest exponent. And so on number 4 here, I see that the greatest exponent is 2. So I'm going to say degree 2. The next thing I'm going to state the leading coefficient now. I know it's part C, but it's always the number in front of that biggest exponent. So in this case, it's going to be 5. So those are very much connected there. And then lastly, it's a monomial, binomial, or trinomial. I see 2 terms here, so this is a binomial. All right, same idea here with number 6. So the biggest degree would be right here. It's actually the first degree. So I'm going to say this is degree 1. It's a linear function. And then I see that the number in front of that biggest degree is 6. So my leading coefficient is 6. And then this is another binomial because we have 2 terms. All right, simplifying these radicals, we're going to multiply the outsides together. So that's really negative 1 times negative 6, which is positive 6. And then I'm going to multiply the inside of the radicals together. But I just kind of multiply them like this because what I'm going to be doing next is breaking them down. So I kind of keep them a little bit separate to save me some time here. But you know what? What would be easier here is that if I break this down to 6 and 2, and I just keep that as a 6 so I can pair those up right away. You could break it down further and then pair them up later, but I just like if I can pair them up earlier, it's always easier. Then I just list out how many r's I have. So I really have 5 here. So I have 3 and then I have 2, so that makes 5. And so I need to pair those up as well. So I had the 6 already outside, so I'm going to keep that outside. And then I'm taking out another 6 for those twins. And then I'm going to take out an r. I'm going to take out another r. And then inside of the radical, we have one loner 2 and one loner r, so that'll be 2r there. And so I'll just simplify this by saying 36r squared on the outside and then 2r on the inside. All right, next up we want to rationalize these denominators, but I need to first, I can actually simplify this. So anytime you can do that, it makes it a lot easier. So this will just be rad 5 over rad 2. So then the only thing I need to multiply is whatever radical is on the bottom, but it makes it a lot smaller numbers if you simplify first. And then whenever you do this, you should get a perfect square on bottom. So I'm going to change that into a regular 2. So I get rad 10 over a regular 2. All right, next up, number 12 here. So the first thing I'm going to do is I'm going to send in the 4th power to the all the exponents here. It all multiplies. Everything else, though, is going to stay the same. So I'm going to remind myself that's a to the 1st, b to the negative 1, 2 to the 4th, a to the 8th, and then b to the negative 8th. And then the bottom's going to stay the same. The next thing I always like to do is get rid of negative exponents. So negative exponents always move. So this b to the negative 1 is going to move to the bottom. All the positive exponents will stay up top, but this b to the negative 8th will move to the bottom. And then, let's see, this 2 to the 1st will stay on bottom. The a to the negative 4th will move to the top and become positive, but the b to the 4th will stick around. All right, next up, I'm going to combine any that are on the same level. So I see I have a lot of a's up top. And so that's going to give me a to the, I add all those up, I get 13. I got a lot of b's on bottom. I'm going to add all those up, so that'll be 9 plus 4 is 13. And then I see that with my 2's, since they have the same base, I can actually battle them out. And it's going to be 2 to the 3rd on top because the top won by 3. And then the last thing I would do is just simplify that numerator. 2 to the 3rd power is, of course, 8. And then, so times a to the 13th over b to the 13th. All right, next up, we're just going to be doing some distributing here. So we multiply that in there. So it's going to be 8a plus 12, and that's it. All right, same idea here. We're going to be distributing that in here. Now, for these ones, we multiply the exponents, we multiply the regular numbers, and we actually add the exponents. So that'll be v to the 3rd. This one will be negative 15v squared, and then a plus 5v. All right, these ones we need to distribute first and then combine like terms. So on this one, I'm going to distribute that in there. So that'll become 8r to the fourth. I'm just multiplying by 2 here, and then 6r squared. And then here, I need to distribute that positive 2 as well. So that's going to be 4r to the fourth plus 2 plus 6r squared. And then we'll go ahead and combine like terms here. So I have 12r to the fourth. And my r squareds actually, you can see here, they have a positive and a negative, so they add up to 0. They cancel out. And then I just have a plus 2. All right, next up here, we're going to distribute this n squared, so that'll be 8n squared. And then this will be minus 3n to the third power, because we're going to add that exponent. And then here we need to distribute the n, so that's going to be 2n squared, 7n to the third, minus 4n. All right, so then next up, we're going to need to combine like terms here. So I like to do these in order. So I have negative n to the 3n to the third first, and then positive 7n to the third right there. So that's going to make 4n to the third. So remember now that we're adding, we don't change the exponents, we just add the numbers in front. And then next up, my n squareds, I got positive 8 and I got positive 2, so that makes a positive 10n squared. And then lastly, I got negative 4n, so that goes there. All right, next up here, this one, there's nothing to distribute in the first one, so I'm just going to rewrite that as is. And the second one, I need to distribute the negative 3, so that's going to make negative 6 plus 3x to the third. So now we'll combine like terms, so I'll get my x to the thirds first. So I got positive 1 and positive 3, so that makes 4x to the thirds. I don't have any x squared, so I'll just go to my x's now. So I'll color code that, so I have just 8x, nothing to combine with. And then I have my numbers, so I have positive 4 and negative 6 makes negative 2. All right, last step here, number 24. So on this one, we do need to distribute the 2 into there. So we get 4k plus 6. And then here we distribute that in, so that's going to be negative 6k, not x, it's k squared. Since that's first power and first power, we add those exponents up, and then plus 6k. Now we'll combine like terms, so negative 6k squared has nothing to combine with. And then 4k and 6k is 10k. And then 6 doesn't have anybody to combine with, so there you go.